So thank you very much, Sergio, for the presentation. I'm Crina Cojocaru. I'm belonging to the physics department of the Politècnica University of Catalunya. And right now I'm coordinating this interuniversitary master in photonics together with my colleagues from the 4 different institutions that Sergio already mentioned. So my goal today is to, first of all, to explain you in few words why photonics is so important. Since I don't know exactly which is your background, we are not in a room where I can see your faces, so I just can guess that you are coming from different backgrounds and you are at different moments into your career. So I will start by a few slides explaining what photonics means and which are the implications into science and technology. And then I will shortly present our problem. Okay, so probably most of you already know that photonics is what we call nowadays the science and technology of light, having in common that all the applications, both scientific and technologically, are implementing photons, light, as an extraordinary tool of exploration. So nowadays, the fields of applications of photonics are very, very broad, both scientific and at a technological level. We do not talk only about optics and physics, as in the last, let's say in the last 15, 20 years, but we talk about applications in physics, chemistry, of course, telecommunication, material processing, almost any kind of modern engineering, biology, medicine, even heritage and environmental science, and so on. We could continue. So actually, photonics, it is the revolution of the 21st century in these terms. Okay, of course, together with electronics, chemistry, material science, all these tools makes possible most of the technological application that we use in our day-by-day life. So you will not probably be surprised that if you talk to somebody a little bit older than you, the new students, in the past, optics was a very interesting field of science. So optics is very ancient. It's probably one of the first sciences that attracted the interest of the people, because most of the information we have comes from images. So we know, we observe our world through images. So optics is a very old field. Terms like classical optics, geometrical optics, photoemitters, detectors, sensors, optoelectronics, and even optical communications are terms that we know since quite a long time ago. However, nowadays, when we talk about photonics, we hear terms like high-power lasers, material processing by laser, nanophotonics, plasmonics, metamaterials. In energy, we also talk about solar panels, green photonics, blue photonics, controlled nuclear fusion, quantum optics and technology, of course, which is one of the hottest spots nowadays in science and technology, and so on. So as you can see in this slide, in order to cover all these fields, we need a lot of people coming from a very multidisciplinary background. And we need people to know optics, engineering, real science, chemistry, and so on. Another thing that I would like you to keep in mind before presenting our program is that photonics is actually a very young branch in science and technology. Probably if you belong to the new generation studying in the last 5, 10 years, you hear this word quite often. However, just to keep in mind that it's a young branch, you can see that the interest in photonics from the economical and political point of view started in 2010, so just 10 years ago, when Europe decided that photonics is one of the key enabled technologies. It means it's a very interesting field for the development of science and technology in Europe. And I'm very happy to tell you that only 2 or 3 months ago, in March 2020, this lists of key-enabled technology are defined for 10 years. So photonics has been renewed 3 months ago for the next 10 years as one of the most important fields in technology. So that's a great news for us. It's a great opportunity for science and technology in the next 10 years. So in 2012, United States also declared it as a very essential technology for the nation. China and India came a little bit later. In 2015, so only 5 years ago, we celebrated the International Year of Light, where people realized that photonics is a very important thing. Of course, all these things are possible thanks to years and years of research, basic research that generated in the 21st century 10 Nobel Prizes in physics and chemistry related to photonics. If we go at the market size in investment, more interesting to look to the graph is that photonics is the market that had a higher annual growth rate in the last years, even if we were traversing an economical crisis at the international level. So all these segments in photonics that you can see here, displays, IT, medical and life science, lighting, and so on, have a very important growth in technological level. And if you want to get better insight into the technological application, I advise you to take a look to the SECPHO webpage and look in the different segments. They are grouping the companies participating into the cluster. It's a very nice definition. I just grabbed the header of the different sectors the companies are grouping on. So having in mind all these things, even 15 years ago, when photonics were just about to generate the technological boom, all the institutions around Barcelona, the 3 universities and the Institute of Photonic Sciences, decided to design and to offer a joint master to cover as much fields, let's say, related with photonics as possible. And we were lucky because in all these 4 institutions, there are a lot of professors, a lot of researchers, a lot of people known at the international level, I would say, that undergo a very high quality research relating to photonics. So we have started 13 years ago already in 2007, a program of 1 year, 60 ECTS, where more than 50 professors coming from all these institutions are telling their experience to the students. All the program is taught in English, so international students are more than welcome. More than this, a part of our collaboration at the local area of Barcelona, our program is part of a bigger program, an European Erasmus program of 2 years with 5 different partners. It's coordinated by the University Act Marseille in France, but then Cultural Institute of Technology in Germany, Tampere University in Finland, and Vilnius University in Lithuania also participate. Students coming from this European master program join our program as one more student. We do not, let's say, we do not have particular courses for the EUROPHOTONIC program. We just welcome them into our own courses, so they become part of the team. A part of that, we have every year 5, 6, 7 foreign students coming from other programs in photonics in Europe. Again, they are joining the same courses that we offer for our local program. So as you can see, it's international community, both from the professor and scientist point of view that teach in this master, as well as from the students' point of view. So it's quite a nice ambience into our program. The objectives of our program, the most important objectives, is to provide you with students with knowledge and training in different areas of photonics. As you saw, it's not enough to design a program that would be specialist in material processing, let's say, or another program that would only talk about optical engineering, or another program only talk about high power lasers. We need different tools because we never know where you will end up in your career into the future. So our main objective is to provide the students with a flavor of, first of all, how many different fields we can have in photonics, and then a general idea about which are the knowledge that you need in order to continue your career in a fundamental direction, let's say towards a PhD and further working in science or in a university or in a research lab, or going towards the applied side of photonics, which means a company, a spin-off, even start your own company, and so on. This is why we understand that we have to be very flexible. We let students choose from all the elective courses we can offer, and you see there are quite a lot. Of course, we guide them to choose those courses that are more interested for them, but in general, we let the student choose which is the kind of training, the kind of elective courses they need to focus, let's say, in the trajectory they are thinking about when they start the program. Our program then prepare the students equally for making a PhD thesis or to work in a campus. And taking into account the multidisciplinarity that you saw at the beginning about the program is addressed to a very broad background students. If we look to the statistics, maybe half of our students are coming from physics or physical engineering, but the other half are spread between different engineering careers, telecommunication, electric and electronic engineering, the degree in optics and optometry, and then in the last years we had quite a lot of interest from students coming from nanoscience and nanotechnology, industrial engineering, material science, biotechnology, and so on. The program is structured in two, let's say, main blocks. The first block includes the compulsory courses. Here we offer courses where the student can get all the needed background in order to be able to follow later the elective courses. Okay, so this is a very difficult balance because students are coming with different baggage of knowledge, let's say, from the previous bachelor. However, a common effort is especially dedicated to these two courses, Introduction to Photonics and Beam Propagation Fourier Optics, where everybody is consolidating things that maybe they heard before in the bachelor, but especially things that they never learned before, and they can build a very strong background for the elective courses. Then we have another two compulsory courses. One is experimental, let's say laboratory in photonics, and the other one that I think is very interesting, especially for the people thinking going to a company in the future, is dedicated to business and patents in photonics. It's an additive key competence, which is, I think, very interesting for everybody because usually nobody tells us how to write a patent and nobody tells us what we have to do if we want to build our own company. After that, the elective courses are grouped, let's say, in four different, I don't want to call them specialities because nobody will be specialist in a field of photonics when you finish the master in photonics. But I would call them subjects, let's say, in order to, when you are looking for which courses I would like to choose, it's good to know how you can group them in different areas. So we have the quantum optics and technology, optical engineering, biophotonics and imaging, and then materials and nanophotonics. Finally, the master thesis complete the credits up to 60. Which are the courses in each of these branch? I will not enter into many details. My colleague Jordi Montpart will explain you a little bit better. As an example, since we cannot in this webinar talk about all the subjects that we are treating and studying in this master. We choose only one. And in this webinar, as an example, we will talk about quantum optics and technology. If we have the chance to present our program in the future, we will probably choose optical engineering or biophotonics and imaging. Okay, so if you have the interest in knowing the details of all these courses, I encourage you to go to the webpage of the Master in Photonics, and there you can enter one by one and see exactly the index and the name of the professors. Even you have a CV of each professor to see the field and the expertise it has in the field, and you will see all the details. Of course, if you have questions, I will be very happy to answer at the end of my presentation. So optical engineering is mostly dedicated to people interested in joining companies later with knowledge about laser systems, optical design, sensors and detectors, measuring with light, fibers, and telecom, while biophotonics and imaging block, let's say, is mostly dedicated to the people who would like to work in medicine, in diagnostic, in active and spectral imaging, visual optics and biophotonics, image processing in general that can be applied to any system, and so on. And finally, these elective courses that you can find under the material and nanophotonic and photonic circuits block are useful for any of these three previous branches. There are information that you need to know in order to work in photonics. You need to know about photonic materials, nonlinear optics, nanophotonics, ultra-fast and ultra-intense laser light, optoelectronics, integrated photonics, and so on. So I will not go more deeply into the content of these courses, and I will finish with the block dedicated to the master thesis. I think this is probably the open door that students have into the master in photonics to really start their scientific career, to really join either a scientific laboratory or company. And the proposals we had for this, we said for around 30, we have the double number of proposals every year, coming from not only from the institution participating into the master, but also from external companies. Okay, so take a look to see which kind of proposals do we have. We have the possibility to undergo the master thesis in an external research center, university or company, and also the possibility of international mobility in the case students want to explore other universities. Here I will underline especially the contribution of SECPHO, the cluster of all the companies working in photonics. SECPHO can establish the contact between the students and different companies, and most of our proposals coming from the companies, we receive them thanks to our memberships in SECPHO and their memberships in SECPHO. So this is almost everything I wanted to tell you relating future careers. You will have explanation given by my colleague Jordi Montpart regarding the PhD. So I will keep this output of our Master in Photonics, and then you will have the opinion of our former students participating into the webinar. I just underlined in yellow the careers in photonics going towards companies, which was my point in this presentation. So we have former students working in research and development and innovation programs in different kind of companies, consultant, engineering, high-level and technicians, position for laboratories, technological, and so on. Okay, and of course, we have, and you will see an example now in the webinar, we have former students that promoted their own companies as spin-off companies and other technological-based small companies. Again, if you have the curiosity, go to the webpage. We have a link to PhD and job advertisement, and you see the amount of job advertisements we receive every year for from different campuses. And I think I will stop here. Thank you very much for your attention, and I hope you will join us and you will decide to participate into this very nice revolution of the 21st century called